In this video we are going to look at how we can implement a many-to-many relationship, so that it is possible to select multiple categories for a product. We have two tables, product and category. A product can be in multiple categories. A category can have many products. To implement such a relationship correctly in a relational database, we have to add an additional table. With the junction table product category, we convert the many-to-many relationship into two one-to-many relationships. The table product category has the two foreign key columns product ID and category ID, to store the assignments of products to categories. Let's create a schema for this database structure. We add a new object tag for the junction table. We give it the class name MyCompanyProduct category, and the database table name MyCompany_product category. We add fields for the foreign key columns. They have the keys product_ID and category_ID and are of type integer. Then we define the relationships between the tables. The relationship to the product table gets the alias product. In the other attributes, we define that the relationship is between the local field product_ID and the field ID of the class MyCompanyProduct. Every entry in this junction table corresponds to exactly one product. We add a similar relationship for the class MyCompany category. In the other two tables we define the relationships to the junction table. These are composite relationships, because we want to delete the related rows in the junction table when we delete a product or a category. The values for the attributes local and foreign are now swapped, and the cardinality is many, because the same product can have many entries in the junction table. Save the schema and create the class files and the database tables. When we open an update window in the Custom Manager page, an AJAX request occurs. The request runs the fields processor, to return the data for the form fields. It's possible to use the afterGetFields hook, to customize the behavior of this processor. When we save the changes, there is another AJAX request. The update processor gets executed to store the data. The update processor also has a hook to expand the code. The hook is called aftersave. Here is a short preview of what we are going to implement. When we get the data from the product table for the update window, we are missing the field for the categories. So in the afterGetFields hook, we query the data from the product category table. For this data we define a temporary field called categories. The format is a list of IDs, separated by double pipes, so that it works correctly with the TV type list box multiple. When the data gets saved, we use the aftersave hook. In the aftersave hook, we take the string of IDs from the temporary field. Then we create new rows or delete existing ones in the product category table to apply the changes. To implement this, we first create a new MIGX configuration. We give it the name product, and use the same value for the unique MIGX ID. In the tab form tabs, we add a new field for the name. Then we add another field for the categories. The input TV type for this field is listbox multiple. In the field configs, we enter a JSON object to enable type ahead. In the tab Input Options we fill in the field input option values. We use a @select binding to fill the drop-down with all the values from the category table. In the Columns tab, we add the obligatory ID column. Then we add another column for the name. We select options for the context menu and add a button to add new items. In the tab CMP Settings we define the display texts for the Custom Manager page. In the tab MIGXdb Settings we set the field package to My Company and the field class name to My Company Product. Then we scroll down to the bottom and define the hook snippets. For the AfterGet Fields hook, we will create a snippet with the name Product AfterGet Fields. The snippet name for the AfterSave hook is Product AfterSave. Save and close the config. The next step is to create the hook snippets. The first snippet is called Product AfterGet Fields. In the snippet code we get the record fields from the snippet property object. The record fields are the existing fields from the product table. We read the value with the key object _ID, to get the ID of the current product. Then we query all rows from the product category table with this product ID. With all the category IDs from the query result, we create a string delimited with double pipes. Then we set this string as the value for a new record field with the key categories. This field is used in the update window by the list box. The second hook snippet we create has the name Product AfterSave. In this snippet we use the MIGX helper function handle related links. This makes it very easy to save the string of delimited category IDs back to the product category table. All we have to do is to define the config values correctly. We set the link _class name to the name of the related class My Company Product category. The link _alias is the alias of the relationship from the schema. Post field is the name of the record field with the delimited IDs. ID _field is the name of the foreign key column in the related table. Link _field is the column name where the ID values from the category's record field should be stored. Then we call the handle related links function with these settings and it handles the rest. Let's test if everything works in the Custom Manager page. When we edit a product, we have a drop-down with a selection of all the categories, where we can select multiple values. Saving and then opening the window again, we can see that the categories get stored and reloaded correctly. In PHP MyAdmin, we can also verify that the data is stored properly in the junction table. If you want to show the selected categories in a column in the grid, here is one way to do this. Edit the MIGX configuration and add a new column. Enter a text for the header. The content for field can be an arbitrary value, as we don't have a database field for this column. But the field can't be left empty. In the tab Renderer, select this .RenderChunk as the renderer. Then in the field RenderChunk template, we can enter the content for the chunk to render. In the chunk, the fields from the product are available as placeholders. So we can use the ID placeholder to query the related categories from the database using the MIGX loop collection snippet. Now in the grid, the category names get displayed in a separate column as a comma-separated list. To output the data on the front end, we can again use the snippet MIGX loop collection. In a resource we call MIGX loop collection to loop over all the items of the class MyCompanyProduct. The chunk TPL product is used as a template for each product. Then we create this chunk. In the chunk we can use placeholders to output the fields of the product class. To output a list of category names for a product, we have to call MIGX loop collection a second time. This call is exactly the same as the one we used in the RenderChunk template before. Here we query the data from the class MyCompany category and join it with the data from the junction table via the relationship with the alias product categories. We filter the data by the value of the field product_ID, to only select rows for the current product. We output the field name of the category class, and separate the names with a comma. Then in the resource, we click the View button to check the output. Alternatively, we could also write a custom snippet to output the data. We create a new snippet with the name getProducts. We use the same code template as in previous videos. First we add the package and set a default value for the TPL property. Then we create a new XPDO query for the class MyCompanyProduct. We sort the data first by the product name, and then by the category name. To query the data we use the function getCollectionGraph to get all the data in one query. We query the data from the class MyCompanyProduct, and add the graph as the second parameter. We connect the product class via the relationship alias product categories to the junction table, and from there via the alias category to the category class. In the loop, we can access the rows from the junction table with the function getMany. Then for these rows, we can use the function getOne to access the category and read the category name. We create a new field in the product array with the key categories, and set it to a comma-separated list of the category names. This field can then be used in the chunk as a placeholder. We save the snippet and open the chunk TPL product to adjust it. Here we replace the call to MIGX loop collection with the placeholder categories. Back in the resource, we call the custom snippet getProducts instead of MIGX loop collection. With a click on the View button, we can verify that the output is still correct. To be able to filter the grid in the CMP by categories, we again edit the configuration. In the tab DB Filters, we add a new item. The filter type is combo box. We give the filter the name category filter. We add a label and an empty text. In the field getListWhere, we write an exists subquery to only return the products in the grid, for which an entry in the junction table exists with the correct category ID. To get the options for the drop-down, we use the standard getCombo processor. We set the text field to name and the ID field to ID. The class name is MyCompanyCategory. Then at the bottom, we set the default value to all. After saving the config, we go to the Custom Manager page to test the filter.